Now we're going to get into some of the features and types of models, so kind of carrying on from what we did before. So exponential growth, as we've mentioned, is going to be anything where your graph is going up. Your B value, your growth factor, is going to be bigger than 1. And exponential decay is going to be a graph that is dropping, and your B value then is going to be between 0 and 1. So a lot of times you'll have decimals like 0.3 or a fraction like 1/2 or 2/3. When you draw an exponential growth or decay, so I'm just going to draw growth. One thing you probably noticed when I put it up on the calculator is your graph tends to almost disappear on your axis. And the reason for that is every exponential growth or decay graph has what's called an asymptote. I know it's a very strange word, the P is silent. An asymptote is a graph that the line that a graph gets really, really, really close to but never touches. Every exponential function has a horizontal axis or horizontal asymptote. Horizontal asymptote is going to be written as y equals. Most of them, if it looks like the one I drew, is going to be at y equals 0. However, you can shift your graph up or down, which would create an asymptote at maybe y equals 3 or y equals 5 or y equals -2. This is, again, going to be a graph that a line that the graph gets really, really close to and never touches, and it will always be a horizontal line when you're dealing with exponential growth or decay. A lot of times when we draw it on a graph, just to kind of show it, we draw it as like a dotted line. To kind of summarize this, when you're looking at an exponential growth or decay graph and you have this basic form, we can also do some things with translating it, moving it up or down, left to right, just like we did with a lot of the other functions. So if we're working with exponential growth, you're going to see that B value, as I said earlier, is going to be bigger than 1. If we're working with exponential decay, then that B value is going to be between 0 and 1. B is always positive. Either way, you're going to have a y-intercept is going to be whatever you get when you plug 0 in. Your domain for every single one of these is all real numbers. Every single exponential graph, whether it's growing or decaying, will have a domain of all real numbers. Your asymptote is going to be y equals whatever this value is at the end. Now, if there's no value at the end, then it's just y equals 0. But let's say it was something like y equals 2 times 3 to the x plus 7. It would be a asymptote at y equals 7 because this shifts it up 7 units. And then finally, my range, you're really going to have to look at the picture. My range is either going to be everything up until we get to the asymptote, to that y value, or everything after. And it depends on if it's above or below the asymptote. So if you have a graph like this is going to be everything that is from that asymptote to infinity. If you have a graph like this that's underneath it, then it's going to be everything from -infinity until we get to that asymptote. The best way to really explain it is to do some delta math questions. So let me show you what this is going to look like. So you're going to be doing the ones that are called features of exponential graphs. And what I love about this is they will give you the graph. So you don't even have to mess around with your calculator. So they're going to give you this graph. So the graph is of 1/3 to the x minus 1. You'll notice that it is a decay because it's dropping. And it also, you can tell that because your base value is less than 1. It's 1/3. So it's going to ask you a bunch of things. First, it's going to ask you what type of function. These are all going to be exponential because that's all we're learning about. And what type of asymptote? These are all going to have a horizontal asymptote because they're all exponential. Horizontal asymptotes are always y equals. To figure out your horizontal asymptote, you can either look at the picture and see where does the graph flatten out, or you can look at the equation and see what's after the exponential piece, and you'll notice you have a -1. So that means your value is your -1. Your range is going to be everything above the -1. If you look at the graph, it's everything above the -1. So your range is everything above -1, which is going to be -1 to infinity. And it is it increasing or it is decreasing. And that's going to be what tells you that it's decay as opposed to growth. And the domain will be all real numbers all the time. And on this, it just wants you to do -infinity, infinity. So that's going to be true every single time. So then finally, your end behavior. So on your end behavior, your left end behavior is going to be the left arrow that you see. And what you'll notice is that left side is going up really, really high. So here's how we do end behavior. The left is going to be as we go to -infinity. What's happening is it gets really big. It goes up. So on the left side, it's going up. And the end behavior on the right side is as we go, x goes to positive infinity. You'll notice for this one, my end behavior on the right, it's flattening to -1. It doesn't keep getting lower than that. It kind of flattens out right at that asymptote. So that's what you're going to be asked to do. Let me show you one. I want to see if I can find one that's a growth. Here we go. Perfect. So here's one that is growing. I can tell that's from the picture, but I can also tell that the 3 that's being taken to the x power is bigger than 1. So this is a exponential function with a horizontal asymptote at y equals, and it's going to be at -6. You can see that from the picture. You can also see that from the equation. My range, everything is going to be everything above -6. That's where the whole graph is contained. So the way that I write that is it's going to be from -6 and up, which is -6 to infinity. And it is increasing. It's going upwards. We said it's a growth. And again, the domain is always all real numbers with these. My end behavior on the left is as we go to -infinity. So on the left side, if you look at the left arrow, it's flattening to -6. So my end behavior on the left is going to go to -6. And my end behavior on the right, so right is always x going to positive infinity, is getting really, really big. The right arrow, the one that's heading to the right, is getting really big, going to infinity. And there you go. So that is how you look at exponential growth and decay from an equation and a picture and analyze all the features.